Hello guys, welcome to another episode of GeeklyEDU. My name is Eddie, and today we will be talking about indeterminate forms. So, if you're watching this video, you probably know what a limit is. So let's write just a regular limit here. Limit as x approaches x0 of x. Usually, this is equal to f of x sub 0. Usually. However, this does not happen all the time. Okay? When, let's call this L. When L is different from f of x sub 0, then we have an indeterminate form. What does this mean? Well, an indeterminate form is basically what we get when we have a limit such as limit of x approaches 1 of natural log of x divided by x minus 1. If we tried to just plug in 1 where the x is in the function, we'd see very quickly that we would get 0 divided by 0. And this cannot happen. Okay, this is a big problem. Therefore, we cannot determine whether this limit converges or diverges. Therefore, we need to move things around a little bit. And this is basically what an indeterminate form is what we get when, after plugging in the number that the x is approaching, we get something that kind of breaks the rules. In this case, we're going to call this one a 0 over 0 indeterminate form. Okay? And then basically what happens in these cases is that then we have to go ahead and try to move things around a little bit, do a few tricks to see if we can actually find whether it converges or diverges. In this case, we're going to use L'Hopital's rule, which you can probably find in a different video. If there are any issues with L'Hopital's rule, please drop a comment and we'll address them. And basically after we do that, we're going to be done with 1 over x divided by 1. And the final solution is going to be 1. So then this limit converges, and it converges to 1. However, I needed to use L'Hopital's rule in order to get to that 1. Otherwise, I would have had 0 over 0. So to go from this point to this is basically impossible. The second type of indeterminate form that we're going to be dealing with, we can see in this example. So we have 5x squared minus 2x minus 3 divided by 2x squared plus 300. If we try to plug in infinity, where we see all the x's, we would have infinity squared minus infinity divided by infinity squared. So what's this? Well, that's basically going to be infinity over infinity. Can we tell right away whether that converges or diverges? Nope. So this is another problem, which we're going to call infinity over infinity indeterminate form. So once again, we need to do a little trick. In this case, we could also use L'Hopital's rule. However, we'll do another one just to switch it up. I'm going to rewrite the function as such. You can see this is 5 minus 2 divided by x minus 3 divided by x squared divided by 2 plus 300 over x squared. So basically I just divided everything by x squared. The x squared was multiplying the 2 and the 5 were canceled with the 1 in the denominator. So now I have this. I haven't changed anything. However, if I try to plug in infinity into this limit, into this new, let's say, form of the limit, 2 over infinity is 0, 3 over infinity squared, 0, 300 over infinity squared, 0, and then the 5 and the 2 are still there, So this is equal to 5 over 2. Okay, and then again, going from infinity over infinity to 5/2, it's, again, you can't do it. You need to play around a little bit. So an indeterminate form is basically an invitation to try to change the way that the limit looks in order to find an actual solution. And then the last indeterminate form that I'm going to talk about in this video, please, keep posted for part 2, is going to be limit as x approaches pi over 4 of 1 minus tangent of x times secant of 2x. Okay? And then once again, first thing that I'm going to try, as I do with every limit, is to just plug in the values. Tangent of pi over 4 is 0, and then secant of pi over 2 is infinity. So basically I have 0, something infinitely small, let's say, times infinity, something that's infinitely large. So who wins? Is it going to end up being 0? Is it going to end up being infinity? Is it going to end up being something in between? We don't know. So this is an issue. There's going to be a 0 times infinity indeterminate form. You can see a pattern here. If I had infinity times infinity, it wouldn't be a problem. The solution would just be infinity. If I had 0 times 0, just 0. Problem is when you get these things that, again, just kind of break the rules. So what do I do in this case? Again, I need to rewrite things a little bit to try to see if I can find a way to deal with the limit. Something I could do is switch colors. So I have limit as x approaches pi over 4, 1 minus tangent of x. And then instead of secant is 1 over cosine, right? So I can just write cosine of 2x down here. And then if I try to plug again the values just to see if that changes anything, now I'm going to have 0 over 0, which is still a problem. Remember, this is another indeterminate form, but we already saw that when we have a 0 over 0, maybe L'Hopital's rule can come in handy. And that's what's going to happen here. So I'm going to use L'Hopital's rule. I'm going to take the derivative of the numerator and the denominator separately. And I am going to end up with negative secant squared of x times negative 2 sine of 2x. All right? So then the negative signs go away, and now I try to plug in the value again and see what I get. So in this case, then the cosine of pi over 4 is 1 over square root of 2, so then the secant is the opposite, so it's square root of 2 squared, I get a 2. And then sine of pi over 2 is 1, so I get a 2, and the final solution is 1. So to kind of sum everything up, indeterminate forms are basically what we get if we try to solve a limit by plugging in the value that the x is approaching to, and we get a solution that doesn't make sense. We have 0 over 0, infinity over infinity, 0 times infinity. So since we can't do anything about that, we can't really tell if it's convergent or diverging, then what we're going to do is we're going to move things around a little bit. We're going to use little tricks to try to find something that eventually I can just plug in the numbers and get the answers that I found here, here, and here. So I hope this was clear, guys. If it wasn't, please drop a comment and we'll try to address it as soon as possible. And please, stay tuned for part 2. Don't forget to like and subscribe. We are posting videos almost every day. And yeah, I'll see you next time.